Can start now.
Okay, ma'am. Everything is related to everything else, but near things are more related than distant things. Waldo Tobler, American geographer. Good afternoon, one and all. Myself, Sai Madhuri, Creative Volunteer, hosting 156th episode of Creative Weekend Talks. Creative is a team gathered together to share knowledge. Hence, our tagline is Knowledge Square. Non textual, non academic, non syllabus concepts are mainly focused in our weekend talks. Showing creativity and being active is our strength. The vision of Creative is building constructive thinking on various domains. Through Zoom platform, our weekend talks will be conducted and are live streamed on Creative GBD YouTube channel. Today we have an young and energetic speaker, Dr. Asfa Siddiq, scientist, Indian Institute of Remote Sensing, ISRO, Dehradun, with us to discuss the topic geospatial technology for urban environment studies. To give a brief introduction about Asif ma'am, we have Mr. Akil, creative volunteer. Over to Akil.
Good afternoon, all. This is Akhil, volunteer of Reactive. It's my immense pleasure to introduce today's guest of honor, Dr. Asfa Siddiqui, a scientist at Indian Institute of Remote Sensing (ISRO) since 2014. She did her bachelor's in architecture from Government College of Architecture, Lucknow, in 2011, and master's in planning with specialization in urban planning from School of Planning and Architecture, New Delhi in 2013. She is a triple gold medalist in the field of geospatial technology of urban environmental studies. She worked at NIT Kozhikode, Calicut, based in Kerala. Prior to joining ISRO, she has a research experience of more than 11 years in the field of geospatial technology for urban areas with the focus on urban and regional areas, with emphasis on solar, energy, and environment. Her research coverage towards the understanding of dynamic urban environment and the associated factors for migration and adaptation. She has focused her research towards analyzing the trends of urban heating and urban pollution scenarios, material characterization using hyperspectral remote sensing, inventory of source, controlling to the air pollution using machine learning and bringing out the essence of renewable energy. She has more than 60 publications in the journals, conferences, books, chapters, and short articles. She is a member of professional bodies like IAUC, ISRS, ISG, ITPI, COA, etc. Thank you, one and all.
Nice. Thank you, Akil. Now over to the speaker, Asif ma'am. Are you there?
Thank you so much for the kind words. Shall I share my screen?
You can, ma'am. Yes, it's visible.
Yeah, just a second. Presentation is visible?
Yes, ma'am. You can carry on now.
So I'll go ahead.
Okay, ma'am. You can.
Thank you so much. Today, I'll be talking about geospatial technology for urban environment studies. Through the lens of geospatial technology, how urban areas can be ascertained, how they can be studied for various aspects. I bring out certain case studies which would help you to analyze the urban areas and its various facets. So let me start with remote sensing per se and Indian Earth observation imaging capability. So from spatial resolutions to spectral resolutions, from Earth to ocean to atmosphere, we have covered all the ranges of understanding the Earth system and the that is important for us through the energy is captured by the sensor, and that is how this reflected energy, when captured by the sensor, is converted into a readable or understandable system, which is known as the remote sensing imagery. It has its DN values, or the reflectance data, and the data sets can be read by any remote sensing expert. It can be analyzed and it can further be processed. So if we look at urban areas, the ambit is too large. We can consider various facets of remote sensing within different electromagnetic radiation spectrum. We can also use optical data for certain analysis. We can use thermal data for certain analysis, and infrared data. We can also go about with microwave data for image understanding and reading of data for urban area extraction. Then hyperspectral data can also be used, but for what in urban areas? So we have a range of studies that we have also done, and we would like to give you a glimpse of what we have done using remote sensing data set. So if first we talk about a city, the city structure, in the center of the city, we have a central business district, or the core of the city, and the city evolves with time, or it grows with time. So there are two phenomena that is happening in a city. One, it grows, it expands, and it is known as urban growth, or if it is unplanned, it is also known as urban sprawl. And the other phenomena associated could be regarded as urban densification or compact development. So how remote sensing can be helpful in understanding urban growth patterns. So this is first case study that I am sharing with you. This is Lucknow city. I belong to Lucknow. And we have tried to analyze through three different time periods from 1993 to 2013, having a decadal interval, and have tried to see the footprint of urban area. So this kind of analysis can be done using the satellite data. Here we have used Landsat data with 30-meter spatial resolution, and in the image you can see how we have tried to trace the footprint of urban area with time, and as clearly discernible that in the year 2013 the built-up has extended. It has also extended in certain portions of the city or certain directions that can also be analyzed using Windrow's diagram. Not only built up and non-built up, we can also go ahead and understand the different land cover classes. So if it is urban area associated with the agriculture, then you can have barren land, fallow land, you can have other open spaces, you can have a forest land, obviously you can have an urban or the built up land. So in urban classification, generally the red color denotes the built up area, and you can see that how land cover classification has been meters. So you can use any data that is closer to 25 meters spatial resolution. It is only a rule of thumb. And by this kind of analysis, you can go and zoom into regions, and you can see that which kind of development is promoted due to which factor. So here, if you can see the airport area, this is the airport of Chaudhry Charan Singh Airport in Lucknow, and you can see that how the urban areas have extended in this area particularly. Not only can you trace and understand the spatial regime of growth, you can also do a forecasting mechanism using any machine learning algorithm. You can use built up area and non-built up area as one of the factor, and certain associated factors. For example, if you want to be in a city, what factors do you consider before planning to settle down in a city. It should be a safe space. It should have greenery. It should be free from pollution. It should have access to roads. It should have access to social infrastructure like hospitals and schools. So all these factors can also be used, and factor maps can be created using satellite data. Just you need to know the latitude and longitude of that particular infrastructure or the utility, and you can create factor maps using the simplest technique, which is known as the Euclidean distance algorithm. Using that and using social infrastructure is closely proportional to physical infrastructure. So here we have used three data sets again, and we have used ANN algorithm. There are many other algorithms which can be used, one of which is CA Markov, that is Cellular Automata Markov algorithm. You can also use artificial neural network, which has been used in this study. How do we do forecasting mechanism is that you need to have a time 0 and a time 1, and you predict the time 2. As I said, urban areas generally have an extension period of 10 years. We generally consider that a substantial development takes place within 10 years interval or a decade. So we study at a decadal interval. So time 0 and time 1, if the details of these two time periods are known to you, you can predict time 2 using the factors. And if your time 2 is as per the ground realities of time 2, you can predict it for the future time period. So you validate it with time 2. I can give you an example. For example, you use time 2003 and 2013 imagery to predict 2023, wherein 2023's data is already available for you. You validate and you customize your model accordingly, and then you can predict for 2033. So this is one facet of urban area which can be covered and very well covered with geospatial technology. It is very important from planners' point of view to understand that the city is going to be shaped in which area, it is going to extend in which area, then the infrastructure can be developed in the similar pattern. So it is a predictive kind of a policy driven understanding can be provided through something of this sort. So in the later studies, this is one of the other example wherein for Jaipur we have tried to see the growth scenario from 1993, 2011 to 2020. For growth understanding, we also have, ISRO has two platforms which you can very well avail. One is Bhuvan. Oh, I'm sure you must be aware about the Bhuvan platform, bhuvan.nrsc.gov.in. It has different time periods, urban sprawl data. So you can, if you are in the preliminary domain of understanding urban sprawl, you can definitely visit this site without having to download any data. You can see the statistics of urban sprawl. Similarly, we also have the urban growth monitoring through Vedas, that is an application that is developed by SAC Ahmedabad, the Space Application Center Ahmedabad. And also IIRS, our department, specifically Urban and Regional Studies, has also developed one Urban Cube platform, which helps us to understand the urban sprawl and urban heating effect and urban pollution dynamics over a temporal domain for all the cities of India. I have not put it here, but it is very well available with us. So the
Ma'am, your audio is disconnected, ma'am. Can you please check it once?
am I audible?
Yes, ma'am. In the midway, your audio is disconnecting, ma'am.
My audio is disconnecting.
Yes, ma'am.
Okay, perhaps some internet issue is there.
I think
So how much should I repeat, or how do
no
I?
need.
Okay, I can go.
Continue.
Yes, okay. So also, for those who are the beginners in geospatial technology domain, you needn't have to download the data sets all the time. You can also avail certain platforms, two of which I have already told you, one being the Data Cube, and one at a global platform, which is a global human settlement layer, which has the data for 5 epochs now. Earlier, it was only for 4 epochs. When I say epochs, I am actually mentioning year. So we have the data till 2020 now. You can see 1975, 1990, 2000, 2014 and 2020. The data is available for all the cities across the world. So this kind of analysis, not only for the urban footprint, but also for population density per grid, that is 1 square kilometers, you have that kind of data also available. This is again Lucknow as a case study example that I am showing you. And you can also decipher between, depending upon the density of population, you can also decide that whether it is an urban area or it is a suburban area or a rural area.
Again, we are unable to hear you.
Sorry,
Again, your audio is disconnected, ma'am.
why is it disconnecting? I'm totally not able to understand. Am I audible now?
Yes, ma'am.
Okay, so the growth of a particular city can also be analyzed using spatial metrics. So you can know that whether there is an edge expansion or an infill development taking place in the city. Like as I told you, there are pockets within the city that are not developed. So if those pockets are not developed, there is chances that they develop in the due course of time. So through these data sets, satellite data sets, you can also ascertain that which areas have edge expansion, which areas have outgrowth using certain indices. These indices can be many, like landscape expansion index. You can also try and understand the compactness or the speed of growth. So here, if you can see, this is Bangalore city. And we have used the open source data, that is global human settlement layer. And this is the map of 2015. And just have a look at 2015 and then quickly switch to 2000. So you can see how the growth compactness within the city of Bangalore of affordability. So if through remote sensing, if I can say that if I'm able to track the electricity usage, so how can that be possible? So yes, it is possible. We have satellite data sets like DMSP and VIRS, which covers the nighttime light data. This is one of the analysis that we have done, in which the lights that are captured during the night, and we have total summation of some of or the total summation of lights of a particular area. In this case, we have taken a state example. So all the states of India from 2012-13 to 18-19, what was the growth in sum of lights, and how is it related to the GDP of that particular state? So we have ascertained that using the VIRS data. And you can see that in Bihar, the phenomenal kind of increase in sum of lights has taken place, something around 200%. So another interesting study that we had done in Delhi, not only Delhi, we tried to analyze with detail in Delhi, but for entire India, we have tried to understand the nighttime lights. And here in Delhi, we have seen, and to our surprise, we have seen that the radiance or the lights have decreased over time. From 2015 to 2022, we have seen a reduction in nighttime lights. Now, first it was Delhi, so we tried purchasing capacity of people has been increasing over time. So we tried to understand this phenomena. And in 2015 and 2020, first we tried to see that is there an effect of aerosols? Because if aerosols are present, the backscattered energy will not be received by the sensor. So we used that particular month in which the aerosol effect would be minimum. And still we found a reduction in nighttime lights. So we could relate it through our analysis, we could relate that the kind of lights that are being used in Delhi are different now. We have switched towards the LED lights, and the radiation, electromagnetic radiation spectrum of LED lights doesn't match with that of the sensors picking the capability of the backscattered radiation. So this is how data can also be misleading. It is our duty to put in our best of efforts to analyze the entire scenario and then come to conclusions before putting in certain facts in public. All right. We can also use now here I'm switching towards terrestrial remote sensing, because till now I was talking about aerial remote sensing. There is also one facet of remote sensing mapping, and this is an example where UAV data can be used or drone imagery can be used for analysis using machine learning algorithms, how images can be classified. Another important sector in urban area is the energy sector. So how remote sensing or the geospatial technology can aid in this. So this is one example that I want to share with you. This is the rooftop solar energy potential estimation for Gandhinagar city. We started with this. We wanted to see that whether all urban centers receive the same amount of solar radiation. Within the urban center also, does the surface and the roof receive the same amount of radiation or not? So, and here three-dimensional data comes into picture. So we have used a digital surface model, and a digital surface model is nothing but made using a stereo pair imagery. Here we have used worldview data, stereo pair data of 0.5 meter spatial resolution, and at 2.5 meter spatial resolution we have prepared the DSM, digital surface model. And the digital surface model, apart from the other inputs like the latitude and the longitude, the transmissivity of the atmosphere, the day, the time, etc. These inputs, albedo being one of the factors, we have tried to ascertain how much is the solar radiation falling on the rooftops. Now here we have used 30% of the rooftop area and 15% of panel efficiency. So in one sector, here I show you the details of one sector of Gandhinagar only. And here in the first sector, the one sector that we had taken, to 50% of energy recovery was possible using solar rooftop panels. So this gave us an understanding that how energy dynamics can also be understood. So we went ahead with this study and we took the entire city of Gandhinagar and tried to estimate, and also tried to build in a decision support platform wherein a WebGIS tool can be incorporated in each on each roof. You can estimate that how much is the solar potential across the different months over the entire year. I hope I am audible.
Yes, ma'am.
Yes, ma'am.
Okay. So
Now disconnected, ma'am. Unable to hear you, ma'am.
Madam, talk is extremely good. If you can log in with one more device, it may be helpful so that we can avoid missing your voice. You can log in with one more device so that.
Okay, just give me 2 minutes. Sorry for the interruption. It is absolutely unintended, but just a second.
Hakim sir, if you can speak until she comes back, let's keep our listeners engaged in about IIRS activities. Is it possible to just have a until to fill this gap, sir? Hakim sir, if you can speak.
It will be a highly unprepared. I may not be
No
doing any
problem. You
justice.
can tell the audience that IIRS is an institute where we conduct a lot of workshop, trainings,
Yeah.
those research, they can go there just to
Yeah.
fill the thing until madam gets ready.
Yeah.
A lot of town planning, urban planning, even forest monitoring, this kind of a lot of research projects will be going on. Both NRSC, IIRS and other ISRO associated like application centers. It could be regional remote sensing centers run by state government. These are all the agencies which are related to today's talk.
Yeah.
Of course, in recent times, there are certain startups also have come up in this domain where they use satellites data for insurance covering, even the weather-related things. Skymet is one such company. I think SatSure is one such company where they are making use of the satellites data and trying to do insurance business. Apart from that, there are so many other, even some academic institutions also, they are coming up to make use of the satellite data to monitor the rivers or even other water resources, which is your field. Just to fill the gaps, some
Yeah,
if
yeah,
you can.
yeah, yeah. Yeah, thank you, Srinath, for this opportunity. Actually, Indian Institute of Remote Sensing is one of the first institute that provided the capacity building for remote sensing and geospatial technologies in the country. Initially, it was part of National Remote Sensing Agency. Now it is an independent center. There is another institution called the Indian Institute for Space Science and Technology, IAST at Trivandrum. The difference between IAST and IARS is IAST is a pure academic institute where they provide undergraduate course, postgraduate course, and PhD courses. Whereas Indian Institute of Remote Sensing provides multiple kind of training programs, starting from 1 week or 2 weeks to postgraduate course in remote sensing. It also provides certificate course on various applications. As Mr. Srinath was telling, the specializations over water resources, urban, agriculture, ocean, geosciences, all the major thematic applications in remote sensing, they offer customized training program. They also host the United Nations institution called Center for Space and Technology Education for Asia Pacific region, SUSTEP. So
Yeah.
overall, the IARS campus has got a hostel, so the students live there. They are having opportunity to do the thesis work in their PG along with international institutions. And the kind of training or the kind of project work that one get to do in IARS is you have a lot of opportunities. And for example, in water resources, you have people working on altimetry, Himalayan cryosphere studies, irrigation
Glacier
water
study.
management, glacier studies. So why each and everything, like what Madam Aspa is showcasing in urban studies, within urban environment, we have so many topics to work with. And it is very great opportunity for people to try out all their research mentality while doing even a training short PG diploma course also you're having opportunity to do some small thesis work. And for the information of those who are aspiring to become future scientists, so IARS is one best platform. A lot of students are JRFs. They have come across the various permanent posts in ISRO. I think she is ready. I will hand it over to Aswa.
Yeah, if madam is ready, maybe we can ask her to carry
Yeah,
forward.
am I audible?
Yes, you are audible, madam.
My,
Kindly.
I am really sorry. My presentation is visible.
Maybe you can share it, madam. We are not
Okay.
able to see.
Okay, just a second.
Yeah, you can share. Meanwhile, Hakim sir, in short question only. See, NRS is Bhuvan also is helping a lot for this one. Maybe shortly we can brief recent NRSC Bhuvan update to the benefit of the audience, and it's coming up. Maybe you can finish
Yeah.
it. One small short.
Bhuvan has come out with a new version of Bhuvan Next Generation, where the people can visualize all the information that is generated under various programs.
Yeah, madam is ready, sir. Yeah.
All right, so absolutely unintended, but a glitch is a glitch. I'm so sorry for the problem. I hope it is functioning now well. Am I audible now?
Yeah, please proceed, madam.
All right. So rooftop solar energy potential is one.
I think again, maybe some issue with the audio.
Data sets, we can have city GML kind of models, which can help us understand the facade development in the case of solar PV estimations. And now, having understood the major aspects of urban growth, the quantification of urban sprawl and urban growth, the nighttime lights, and the energy domain, I switch towards two most important factors of climate change that are pressing at the moment, which is increased temperature, which takes global attention in the form of climate change and global warming, and the other being the increased pollution levels. So let us see that the footprint of urbanization, the greenhouse gases, the increase in aerosol levels, the vehicular pollution, reduced levels of vegetation, increase in the impervious surface areas, how is it impacting and what remote sensing has to offer in such kind of analysis. This is one of my earliest works that I had done long back, but I want to mention it here because of a reason. This is Jaipur city, and we wanted to see the urban heat island effect in this particular city in 1993 and 2013. And we had Landsat data. Landsat, as you know, has a pass of 10:30 a.m. It's a morning data or a daytime data, if I would put it roughly. We tried to use different algorithms for extraction of land surface temperature, which is the skin temperature of the ground. So, but to our surprise and as a conventional understanding that only urban heat islands effect exist, urban areas have higher temperature as compared to its surrounding non-urban areas or the non-urban counterparts. But here we had analyzed that urban areas have lower temperature as compared to the surrounding non-urban counterparts. So this gave us an indication, and this was my first study. So this gave us an indication that urban heat island is a reality, and at the same time, urban cool island or global dimming concept or urban heat sink concept or a negative urban heat island intensity concept is also a prevalent concept. We need to understand that there are certain arid, semi-arid conditions in which this kind of phenomena exists. We validated it using different techniques. We have used split window algorithm, we used single channel algorithm, Mao's algorithm, many algorithms we had used, and also tried to understand the MODIS counterpart, which is at 1 kilometer spatial resolution, but it at least gives us a glimpse of what kind of situation occurs. So we have seen an urban heat sink effect here in Jaipur. But we can't say that urban heating is not taking place. Why do I say this? Because the average temperature as you move out from the city center towards the outskirts, you can see that 1 to 1.5 degree temperature difference has been witnessed in the city of Jaipur, and this graph tells you that. So urban heating due to the footprint of concrete structures is very much a reality. Only thing, urban heat island is a very perspective concept which depends totally upon the non-urban areas. To extend this work further, because it gained my attention and I wanted to study that what is the status of urban heating and also urban pollution and their synergistic understanding and relationship with each other, we tried to ascertain the situation for 53 million plus population cities in India. And overall for the Indian city, we saw that during the daytime, we used a standard Mencken-Dahl test for this kind of understanding. There is a reduction in daytime temperature data, but during the night time, there is an increase. So this also gave us an understanding that if we really want to understand the effect of urbanization on urban heating, we should actually not conclude our understanding only on the basis of daytime data. We should actually refer to the nighttime data for a better understanding. So this was one. And second, how AOD or aerosol optical depth, which is considered to be a proxy to particulate matter, affects this kind of situation. So we have seen that first coming to land surface temperature, because we we wanted to study the urban heat island effect using land surface temperature. You can also study it using air temperature. When you use air temperature for this kind of analysis, heat island effect is known as atmospheric urban heat island, and the moment you use land surface temperature, it is known as surface urban heat island effect. So there are subdomains to atmospheric urban heat island also. I'm not going into the detail. Anyone interested can go and read. Okay, so the study was conducted from 2001 to 2018 in phase 1 and 2001 to 2019 in phase 2. But we also saw that during the day and night time both, there were certain years in which there was an uncertain peak of land surface temperature from the usual trend in India. So 2009 and 2016 showed us a peak of land surface temperature beyond the normal or the average values of different years. So this was the effect of El Nino, which triggered the heat wave events and which is easily understood using remote sensing data sets. Similarly, during the daytime and the nighttime, what is the value of surface?
Audio problem.
Cities have had shown a very high, significantly increasing trend. We have tried to understand the land surface temperature trend for different Köppen climate classifications also. Similarly, for AOD, we have tried to ascertain these trends, and you can see that AOD has been rising in urban areas, but it is also rising in non-urban areas at the same intensity. So why am I studying urban and non-urban? One, I want to know the intensities of heat island, and I also want to know the intensities of pollution islands, because lately we have analyzed that just like urban heat islands, there is also something known as urban pollution island. And to know that intensity, we have tried to analyze for urban and non-urban both. So supposedly, if the non-urban areas have a higher trend or an increasing trend more than that of urban area, the urban pollution island intensity would be lower. And that is what we have seen in the Indo-Gangetic Plain specifically, that the non-urban areas, that means the amount of sprawl and the amount of development in the non-urban areas are increasing. And also that air pollution is a regional phenomena. It is not covered only with urban specific domain, but definitely urban areas have more factors contributing towards that pollution. So this is the AOPI, the average atmospheric urban pollution island, that is the mean from 2001 to 2018. Again, we have tried to analyze this across different climate zonations. There is a lot to it. Let me just sum it up for you. We have seen that there is a straight correlation between AOD and LST, but it is not so simple as it appears to be here, because aerosols are of different characters. They are carbonaceous aerosols, there are surface sulfur-driven aerosols, and all have a different effect on either warming or cooling. Overall, aerosols have a negative radiative forcing effect as perceived through IPCC report. The ecology of an area can also be ascertained. Here we have used a remote sensing based new ecological index derived by us, wherein we have also used urban pollution parameters to see the ecological situation of the city of Delhi. Now here I want to just spend half a minute and tell you that this boundary of Delhi doesn't look quite like Delhi that you have seen wherever you have. So this is not the NCT of Delhi. This is the urban Punarbeshan boundary of Delhi, which takes into account Gurgaon, Faridabad, Noida, Greater Noida, Ghaziabad. So urban footprint or the continuous or the contiguous urban footprint has been analyzed, wherein the footprints give you a clear indication of heating or cooling effect. So if you look at the nighttime data, you can see that from 2011 to 2018, how the nighttime data gives you a clear-cut understanding of urban warming. However, the daytime doesn't suitably provide you such insights. So the ones who are using and AOD for the futuristic domains. Now, when we are purely into research and we want to do it, such kind of data sets we have used, sometimes it becomes very important to see the impact of one event. For example, if an earthquake comes in, or for example, during the COVID time, when we wanted to see that what is the effect of COVID. So when most of the people were trying to analyze the urban pollution effects, which I have also done, I also tried to ascertain that what was the effect of lockdown over the heating phenomena. So we have seen that there was a reduction in nighttime as well as daytime heating effect, and the urban heat island effect, intensity increased during this period because the non-urban areas seemed to have cooled down more as compared to the built-up area, because the other ancillary factors like the anthropogenic factors introducing urban heating might have reduced, but the footprint of concrete remains there, and the long wave radiation from the concrete structures remain there, which pronounced the heating effect in urban areas, but the non-urban areas got an environment in which vegetation thrived. So the impact between urban and non-urban increased. This was done using Landsat and MODIS both. The energy budget of the atmosphere and the ground between anthropogenic activity, which includes the metabolic activity of the humans. So from 1993 to 2020 in Jaipur, you can see how the anthropogenic heat flux has increased. All this has been done using remote sensing data sets. There are a few steps involved in which we try and ascertain land surface temperature, sensible heat flux, latent heat flux, stomatal resistance, etc. Vegetation is involved, and the 3D canopy parameters are involved. So all this included gives you anthropogenic heat flux. And this is very important to analyze, because anthropogenic heat flux actually tells you that how much more you are adding to the atmosphere in terms of heat. Many cities have shown urban heating as well as urban cooling effect. If you look at the daytime phenomena for the cities, most of the cities do not show a pronounced urban heating heat island effect, but during the night time they do show. Pune, for one of the example is Pune also showed a urban cooling effect during the daytime. I'll give an example here in Lucknow also. Look at these areas in 2018. These are what? These are not urban areas. The urban areas are restricted to the boundary that I showed you. What are these areas? These are agricultural fields which have not been in cropping system for that particular most part of the year, because during the summer season these areas are already the crop has been removed, and these areas behave like barren fields. Now, switching from urban heating to urban pollution, and not only remote sensing, ground-based data can also be used. So we have two instruments with us. Using those two instruments, we studied the traffic parameters, the morphological parameters the meteorological parameters and the air quality parameters. And we have done extensive data collection for this. So this is 23 locations that I'm referring to. So in phase 1, we took somewhere around 8-9 stations, but in phase 2, we took 23 cardinal points in Dehradun planning area boundary. And these areas were near the roads, and we wanted to see that how much is the pollution being recorded by our sensors, both particulate matter and gaseous pollution. And we also wanted to model that supposedly if we do not have stations across the city. For example, Dehradun only has 3 stations for CPCB, and that too is not connected to the central system of CPCB through which we can have the data. So in such a scenario, if everything is known to us, the meteorology is known to us, the morphology is known to us, the vehicular and the traffic information is known to us, can we predict how much is the pollution? So we used to this was a routine that what is the concentration across different stations that we have. So we wanted to see that what is the pollution dynamics, and can we do it? Can we understand it? So we used 2 models. One is operational street pollution model, and the other model which was atmospheric dispersion monitoring system. And very well, with the help of these 2 models, we were able to have a synergy between the modeled and the observed values. And we were also able to model using the this only for a few months to it as well. Again, like a lot of people have done, but I proudly say that this was the first study from ISRO that was published in urban air pollution reduction. So we used Sentinel-5P tropomi data, and we saw the reduction in NO2 levels during the COVID lockdown. The phase 1, that was from 24th March to 7th of April. And on the left hand side, the A image is 2019, and then on the right hand side, it is 2020, the same time that I told you, 24th March to 7th of April. And you can see the hotspots of cities as the primary emission sources are not visible here. But can you see these areas which were there in 2019 also, in 2020 also? So these remained. Why? Because we were getting our electricity from these areas. So these were the thermal power plant locations. We also tried to analyze the relationship between corona positive cases, the mortality, with the long-term exposure of nitrogen dioxide. And we have seen that 61% of the fatality cases were observed in 8 major cities of the country alone, coinciding with locations having high long-term NO2 exposure. I don't say that there are not other conditions responsible for it, because cities only reported data at that time. But yes, even if it was not 61%, it would have been 45-50%. But you see how long-term exposure of nitrogen dioxide is having an impact on our lung functioning. So, yeah. So this kind of work can also be done using ground-based data sets. It can also be done using Sentinel-5P tropomi data sets. Why I'm mentioning Sentinel-5P? Because for urban areas, you need to have a good spatial resolution to narrow down, right? So here, Sentinel-5P gives you a data at 3.5 by 5.5 kilometer spatial resolution, a resample to 1 kilometer at certain platforms like Google Earth Engine. And at 61 stations of Delhi urban agglomeration, we have done this analysis. Here you can see the NCT, and the footprint is this one. Okay. So yeah, this kind of analysis, how much was the reduction and such kind
Sir? Srinath, sir?
13th showed the maximum reduction. All right, so here I switch towards, we have understood how much is the pollution. We have also seen how it got reduced. Now, let us see that is Delhi's pollution only Delhi's pollution? Or is it being affected by certain other sources of pollution as well? So we tried to do this with the help of back trajectory analysis. Here we have used concentrated weighted trajectory modeling for the first time for gaseous pollution. Now, most of the studies that you will see would be reporting particulate matter 2.5 or 10. Many of the studies have not focused on carbon monoxide, nitrogen dioxide, sulfur dioxide, and these are all sources that heavily pollute Delhi. So we have seen that which areas are actually contributing towards the pollution of Delhi, in which season it is contributing towards the pollution in Delhi. And we have used two types of models for doing this analysis for source, not only source attribution, but also for source apportionment. So using chemical mass balance equation, we have seen that the domestic sector burning actually is contributing towards a lot of pollution in Delhi. Transboundary pollution is also affecting our pollution in Delhi. Apart from other sources, which you already know, stubble burning has been, told time and again that it is actually contributing. The other sources, which is little less heard of, like we made a brick kiln inventory for entire northern India. So brick kiln is actually contributing a lot towards pollution in Delhi. And obviously the fire through stubble burning, so direct correlation during the post-monsoon season, and the onset of winters in Delhi making situations aggravate due to the shifting of cultivation pattern in Punjab and Haryana, responsible for this kind of pollution episodes. So winter, summer, monsoon, and post-monsoon, all having its own reasons. If somebody is interested, can go back, read the papers that are published on all of this. And the suggestion that we gave during the analysis of this was that it is very important to have policies for pollution, not only city specific, but airshed specific. So the airshed was delineated using remote sensing data sets here in our study. And not only CMB, chemical mass balance equation, which generally CPCB is using, we also went ahead with modeling platforms like WRF, Weather Research and Forecasting Chemistry Model, and we did the source contribution, the source apportionment analysis for Delhi, Northern Delhi. One interesting study, I think I'm closing now. So one interesting study that I want to see talk about related to pollution is that recently EMIT data was released, and EMIT was actually planned for the monitoring of the dust, mineral dust. But here, since the sensitivity of the data made it capable to give you an example here, you can see on the right hand side in Tinsukia, Dibrugarh in Assam, you can see that there is an oil and gas field, and its leak can be captured by tropomi data. So this is how data sets can be used. So here you can see that this is the Piranha landfill site in Ahmedabad using EMIT data. And here we have used our own research techniques of wind rotation, wherein we have used Sentinel data to pinpoint the Piranha landfill. So I think it is comparable. Only what is not comparable is the spatial resolution. Here we are talking about 70 meters spatial resolution, and here we are talking about something around 3.5 kilometers resampled to 1 kilometer. So methane enhancement becomes one of the cutting edge fields where remote sensing can effectively be utilized. And it has also been validated in Delhi through various reports that have been published. Just a quick understanding that hyperspectral data can also be used for urban material understanding, and we have used AVRIS-NG because it was a part of AVRIS-NG mission, and how different materials can also be mapped. I mean, we are actually going ahead from urban sprawl to material dynamics using geospatial technology. So you can see the wide ambit, the wide gambit, which is being covered by geospatial technology: marble, iron, concrete. In detail, I can show you. This is asphalt, and you can see that how beautifully the asphalt roads have been highlighted with the help of hyperspectral data. And yeah, so this is something which I wanted to do. I still want to do. I'm waiting for the right data. So here we have 8 meter spatial resolution hyperspectral data. Above this is the land cover. Not land cover, this is the material map actually. And here we have the Landsat data of heating, that is the LST data. I wanted to relate the material dynamics with temperature. So this is something that is ongoing in my mind. We have done, why I'm not relating too much to this at this point is because spatial resolutions are different. Everything changes when you go to a micro scale, to a micro scale, to a meso scale. So 8 meters to 30 meters, not comparable, but still we have been able to identify pockets where association factors play a pivotal role. So where asphalt is only, it's dominated by asphalt and concrete only, there the asphalt's temperature is more as compared to planned developments wherein you have open spaces as well, there the asphalt is lower in temperature. So I have told you about problems till now, and the problems do not not the only thing that research holds. Research is all about knowing the problem, modeling the future, and also doing something for its mitigation. So some of the tips that we have collected through literature and through modeling exercises. However, I'm not an expert at the moment, but we need to have certain strategies for mitigation as well. So some of the mitigation scenarios can be cool roofing and vegetation. And for pollution also, we need to have mitigation understanding. Of which one that I have told you, it should be more airshed specific than the city specific policies. So I think I am on time and I have completed what I had to say. So if there are any questions, I'd be happy to answer.
Yeah, thank you. Now thank you. The forum is open for questions and any discussion. You can unmute and ask the question. I have one small question. When it comes to the urban, what you call urbanization, there are certain areas which were earlier called as a green areas inside the urban. Now that is getting disappeared. But due to the what you called urbanization also, is there any signature of green coverage increasing? Is the question.
Oh yes, definitely. In Jaipur also we have seen increase in green cover. In Delhi, if you see, after Commonwealth Games, the green cover has increased. So there are examples in which green cover has increased, and that is very much doable using remote sensing.
No, that's a good inference, because many people always say city बढ़ रहा है इसलिए plantation कम हो रहा है, but there are certain signatures. City also will increase the plantation where earlier agriculture is being done. Agriculture greenery is a temporary greenery, whereas plantation greenery may be a permanent greenery, right?
Yes, vegetation has its own evapotranspirative cooling mechanisms. So definitely plantation or vegetation is going to have an impact. But again, it's an area of research. How much plantation is going to have an impact? In what quantity, which type of plantation? For example, Jaipur's outskirts also has plantation, but which plantation? It has kikar and it has babool, which has no foliage, which has no evapotranspiration, no moisture content. So it's not adding to the relief of the city. But within the city, it has organized plantation, which is also helping in mitigating the impact. So this way may be a reason of cooling as well.
Thank you. Anybody has a question, please ask your question.
Yeah, hi. I'm
Please go ahead.
Dr. Manoharan Krishna, associated with Anna University. I really appreciate Asfa Siddiqui for your elaborative at the same time crispy presentation. I have a good suggestion. Being organic agriculture scientist and eco-agripreneur myself, operating in many countries across the world, while selecting the trees in urban area, it is mandatory and it is inevitable today to plant a selective plants like pupils tree and evergreen tree like pungamia tree, and also bamboo, which is not growing very tall, and at the same time bushy bamboos, which are well known for releasing excessive and adequate quantity of vital oxygen. So we people like us, well accomplished and also exploring various greeneries around urban areas, and also eco accommodation, what we are trying to do in urban area. It is very, very appropriate and also important to select the trees which I'll be able to support, whichever country or whichever city you need, I can support. Professor Ravi Kumar and Professor Saravanan of Anna University can route it. You can route it through them, and I can easily support you people. And really appreciate this kind of forum, which is need of the hour for entire world. Yeah, I very strongly suggest this. Select the plants which supposed to be planted to release moisture content as well as oxygen, vital oxygen content. Please.
True, sir. Thank you so much. And first of all, thank you for your appreciations. And this is very well a matter of research, because the impact that all these strategies of mitigation can have over heating has to be explored, because we have often dealt with the problems of urban heating and pollution. We need to now switch towards the mitigation aspects as well. We need to understand what is helping us to dilute the problem. So in this way, as you said, landscaping of the urban areas in a specified domain can help us beat and combat the problem. So thank you so much, sir. I have noted down
because we have created almost 360 acres of eco agricultural farm near Vellore, where I already shared with one of the sessions in Society of Water Sources. And when you people professionals visit that farm, you can easily make out how we have eco-friendly and very how to say that, a professional way. The running away water has been made as a cascade system. About 14 cascade system is available in and around our farm. And also the sunlight harvest is 100% we are harvesting. Not even 0.1% sunlight is falling on our agricultural farm ground level. All the sunlight, entire quantum of sunlight is being absorbed by various multi-layer, multi-crop system, and followed by, when you enter into the farm, you will feel as if you are in Amazon forest, because the vital oxygen which is released and plenty of carbon dioxide has been taken for photosynthesis. And this model, if we replicate or we can even simulate elsewhere, this will be working good. And at the same time, the plants which we have planted in Natura Agro Organica, our farm, it's more than now 40,000 plantations are there. Let it be teak wood, let it be red sanders, let it be bamboo, let it be pupil tree, or let it be gooseberry trees and vangai trees, whatnot. We have been planting plenty. And at the same time, we are also techno-commercially utilizing the land and environment for getting more and more yield, because the vital oxygen which is released is again required for other plants which are living one below the other. That is called multi-layer, multi-crop system. So I will be very happy to support all of you to specifically plant such plants across wherever urban cities are available. Please.
Thank you so
Please.
much. Sorry to interrupt you. It is a fantastic information, and we look forward to see how this your work and your activity can also be spread. And due to the shortage of time, I am interrupting you. Don't mind me.
Okay.
Otherwise,
Okay,
very,
please,
very
please.
valuable information to the audience about the nature of the plants and the activity which you have carried out. May I request anybody, because I am crossing my the time. I do not know the end of this one. 4:15 or something it will end. Any other person, Venkatraman, you do have any question? You can ask.
Sir, thank you, ma'am, for this great presentation. It was a great overview of GIS and how it's helping urban systems. So, a question was to ask that.
Can you be a little louder?
Sorry, is it better now?
Yeah, please go ahead.
Yeah. So, as I was saying, ma'am, cities obviously need a plantation, and that plantation comes usually from rural areas that are outside the city. So, as it radially grows, that also means that you have to move that plantations somewhere else so that this can be continued. So, how do you think we plan or we space cities to have a space to grow at the same time?
Yeah, actually, after the city has attained a certain size and it has grown in a specific way, the efforts in putting something externally in terms of vegetation becomes very difficult, because you need to have areas also wherein you can plant in trees, right? So
Yes.
certain other techniques can be taken forward, like can we use PV panels to reduce the temperatures? I don't know, maybe, right? So can we just paint all our roofs white in color? Will that help in non-absorption? Maybe, right? Then maybe on the roof surface we provide vegetative cover. Will that help? Certainly.
Yes.
So this kind of arrangements can be made, but if it is a planned city, right from the starting we are doing the planning of the city, then things
Right.
can be controlled. But I tell you, it's a very dynamic process. Like Chandigarh was planned for a certain population. Right now it has
Yes.
exceeded the population, right? So it's a very dynamic urban growth is very dynamic. You think you can control it, most likely you
Yes.
can't. Yeah.
Yeah,
And
that's
then when it yeah.
Venkat. Yes, Venkat, please.
Yes. And then it gets more apparent wherein a country has more population, like India or somewhere else.
Yeah. There are examples. If you go into planning, there are examples of decaying cities or dead cities also. Okay. So even if you think that cities will always keep on expanding, it doesn't happen that way. Uh, Kanpur, I belong to Lucknow. It's very close to my place, Kanpur. It has a population growth rate of something around 8%. Uh, it is not thriving, right? It has no
Yes.
population growth rate. So with time, the balance mechanism is there. Like Delhi, for that matter, NCT is not supporting any population. Now, it's only the outskirts which is
Right.
supporting. So the NCR is growing and growing. So cities have their own mechanisms. Generally,
Yeah.
our cities have 29 to 35% of growth rate in population terms. Footprint of spatial growth can vary. Like Pune has shown a very high spatial growth rate. Then Surat has shown good growth rate. Okay. So recently, Lucknow has also shown growth. Yeah.
Thank you. Thank you. May I
Thank you,
have
ma'am.
any comments or a question from either Dr. Syed or Dr. Abdul Hakim? If you have any query, otherwise I may have to end up. Please, the
No.
open form for.
Yeah,
These two
please go
gentlemen.
ahead. I have only appreciations, no other suggestions. Please go ahead.
Thank you. Dr. Syed, if you have anything to say, please. Okay. Thank you, all participants. I know the difficulty of keeping you 1 hour in an online session is difficult. However, Dr. Aspa has done an excellent job, both in terms of narration and in terms of presenting the beautiful graphs and the maps and whatnot from the satellite pictures. In fact, in this lecture, the motto of the speaker is to present the research aspects as well as the policy perspective for control or to have a regulated urban/city development. I think she has covered extensively both Bangalore, Lucknow, Dehradun, Jaipur, whatnot, reduced the green coverage, aerosol. Even she has also touched upon the impact of the COVID, where the reduced human activity was there. Madam, it was an excellent, what you called exhaustive and excellent coverage of both the GIS and as well as the various other aspects of human activities in terms of remote sensing applications. I know the tremendous amount of research work being done by ISRO, which is now portrayed to the many audience. Thank you, Dr. Asfa, for your patience, time, and as well as the excellent narration to the audience. Hope everybody will appreciate the same in future. Thank you so much. I think I will ask Madhuri to close the session.
Thank you
Thank you,
so
Dr.
much. I have to thank all my students who have been pivotal and all the fellow researchers also from NRSC who have been very, very instrumental in letting this forward. So thanks to everyone. Okay.
Thank you, Madhuri. You can wind up the session, Madhuri. If you're otherwise, I'll thank you, one and all those who have participated.